Assalamu alaikum students. Uh, Again in the unit properties of matter, we have already discussed pressure. Now we are going to discuss pressure in liquids. In this pressure in liquids, we are going to understand Pascal laws and state it and apply and demonstrate the uses of Pascal law in daily life. So first, what is a Pascal law? Pascal states that the pressure applied to a fluid and closed in a container is transmitted equally in all directions to all points in the fluid, and uh, and equally it is transmitted in all directions. Now, it can be demonstrated with the help of the glass vessels having holes all over his surfaces. Filled it with water, push the piston down. The water rushes out of the hole in the vessel with the same pressure. The force applied to the piston exerts pressure on the water, and this pressure is transmitted equally throughout the liquid in all directions. In general, this law holds good for fluids, both for liquid and as well as gases. Now, to understand this, you must watch this video.
Demonstration of Pascal's law. Pascal's law states that when pressure is applied at a point in a confined fluid, it is transmitted equally in all directions. Let us perform an activity to understand Pascal's law. Shown on your screen is a vessel having a number of openings. These openings are furnished with projecting tubes of section area A, B, C, D. These projecting tubes are fitted with airtight pistons PQRS, which are capable of sliding into the projecting tubes. Fill the vessel completely with the liquid. The only forces acting on the liquid are the forces applied on the pistons P, Q, R, and S. Now push the piston P down into the liquid. What do you observe? We observe that the other pistons Q, R, S are moving outward. Why is it so? This is because the pressure exerted on the piston P is transmitted equally in all the directions in the liquid, thus moving the other pistons. This proves Pascal's law.
Okay, now, so this is what the Pascal law is. If pressure is applied to any point in a liquid, it is distributed equally, it is transmitted equally in all directions. So, what are the examples of Pascal's law in daily life? There are numerous examples, such as the hydraulic brake system, hydraulic jacks, hydraulic press, hydraulic lifts, and hydraulic crane pumps, etc. So there are many. So we are going to discuss few that are based on the Pascal principle. Now the first is the hydraulic press. You see that there are two um, narrow cylinders of different cross-sectional area. This is having a small area, and this is a big area having a big cross-sectional area. It is fitted with a rigid roof. Whatever is we need to press it should be placed on this bigger cylinder having a bigger area, and it is between the roof and the cylinder having a bigger area. Now they are fitted with these two uh, cylinders are fitted with a piston that should be airtight one, and cross sectional area a is the cross-sectional area of the bigger piston, and small a is the cross-sectional area of the smaller piston. So whenever the force is applied on this piston, it apply a pressure in this direction, and this pressure is equally distributed throughout the liquid. So whatever is the pressure over here will be the same on this side. So the the pressure P produces by the small piston transmitted equally to the large piston, and the force F2 acts on A1, and which is much larger than F1. So this, you can see that we are going to prove that by calculations. The pressure is, this is the again the diagram of the hydraulic press. uh, the pressure is on the piston of the smaller area will be P is equal to F1 upon A, and of the other is Fp is equal to F2 upon A. This is A1 and this is the A2. Now, comparing both the equations, we know that the pressure are equal. So these both are equal, pressures are equal, P1 is equal to P2. So F2 by A2 is equal to F1 by A. Hence, F2 is equal to A into F1 by A, or we can write F2 is equal to F1 into the ratio of their areas. Now we know that A is the area of the bigger cylinder and small a is the area of the smaller cylinder. So this should be naturally would be ratio will be greater than 1. Hence the force F2 acts on the largest piston is always greater than the force F1. If the, you can see, if the area A is equal to 2A, so AA will get cancelled and force F2 will be twice F1. In this is hydraulic system working in this way are known as force multiplier, four magnifiers. So a smaller force applied on this smaller piston gives you a bigger force on the larger piston. So this is the working of the hydraulic press. So whenever there is a force is applied on this piston, the thing that is to be pressed is placed between the this roof and this piston, it is pressed. So this is the working of the hydraulic press. Similarly, we have a hydraulic lift. It is there are many kinds and it is versatile in its utility. It has a hydraulic apparatus which is used to lift the heavy object. You can see this is one kind of a lift. It is this is working on a hydraulic system apparatus. The hydraulic In case of hydraulic lifts, force applied creates lift and work. The hydraulic lift technology was widespread application in industry, construction, transport, etc. Now, how this hydraulic lift works? Again, we know that there is a narrow cylinder having a smaller area, and there is a bigger cylinder having a larger area than A1. It is filled with some incompressible fluid. Pressure is applied can be applied to move the piston A downwards. This is should be moved downwards, so the pressure is applied in the fluid, and it is an incompressible fluid, so this pressure is transmitted equally in this side. No, so according to the Pascal principle, to the piston of the cylinder, piston B. Now, consequently, the piston B, because F2, the piston B will move upwards in a hydraulic lift. The piston B is used as a platform for a car or any heavy object to be lifted, like a truck, car, also in playland. So this is the working again the same way, where this is your hydraulic lift. We have a hydraulic jack, jack uh, jacks very well. When your car get puncture, you place a jack just to lift your car underneath it. Now, what is again the hydraulic jacks work on the same principle, that is the Pascal principle, and they are used to lift the heavy bodies. Again, it is the basic structure is same. It consists of two cylinders. One is narrow and other is wide, and it is hand when now you can see that this is somewhat when the handle is pulled. You can see that when this handle is pulled repeatedly just to lift that up, and this is what it is used in your car. This is repeatedly pulled up and down. So when the handle is pressed down, a valve closes and the small piston forces the fluid through another valve to a larger cylinder, which then produces, because the pressure is transmitted equally, so this larger cylinder produces a larger force to be transmitted to the load. Therefore, we can say that force is applied, the pressure is exerted throughout the volume and surface of the cylinder. The handle is moved up and down repeatedly until the load is sufficiently lifted up by the hydraulic fluid flowing buffer tank to the smaller cylinder. Hydraulic jacks are highly advantageous in automotive industry. They are often used to lift cars above the ground level for repair and maintenance. So this is the most important and the common example of hydraulic machines, that is the hydraulic brake system. Uh, Hydraulic brake system present in the automobile. Now, every time when you car comes to a halt, the principle of basket principle come into action. So we are going to see what are the parts of the hydraulic brake system in a car. You see, this is the brake pedal, and at the end of the brake pedal there is a master cylinder, and this is special, these are the tubings. They are provided with the special fluid, incompressible fluid, and all this tubing goes to each wheel, and they are also provided with the pistons. So how it operates, this is the brake shoes, so that the brake shoe, uh, uh, when the brake shoe moves the brake pads, they stops the movement of the wheel. Now, how does it happen? The liquid is known as brake fluid enclosed in the container. You can see that this is the brake pedal. We apply the When we apply the brakes, this is pushed down, which in turn pushes this cylinder in the outward direction. These all tubings are filled with the fluid, incompressible fluid. So this, what happened is that when this pressure is transmitted to this tubing, this causes the other in the other the these two pistons in the other cylinder moves out, and when they move out, they uh, presses the brake shoes, and uh, the brake shoes stuck with the brake, stop the brake drum, just like this. You can see that in over here. uh, this is the moving wheel. Now when this piston move inwards, these are the brake pads. They stop the movement of the this wheel brake drum. So when they this is the your restoring spring. When we releases the brakes, this piston move back to its original shape. There is no pressure in this, so this is storing spring, that is stretched when the brakes are applied, comes back to its shape, taking along the brake shoes with it, and so the brake drum is free to move. So this is how the brakes are applied. These are the brake pads. You can see this piston move outward, and the brake pad stops the movement of the brake drum. So this is a very important application. We The hydraulic brake system, it is applied in all automobiles. Now, just to understand how we all these are the force multipliers or magnifiers, and how these magnifies the force. You can see we can do by numerically we can uh, clear that how much weight will be lifted by a hydraulic system in an auto garage. If the force of 10,000 Newton is applied on a piston of the area zero point 0.5, this is a narrow piston area zero point 0.5, and to the other piston, this is the area 1 meter. So you can see the area of the narrow piston is zero point 0.5, and area of the larger piston is one, exactly the double. Now, how this is going to magnify the force? We know that pressure, according to the pressure Pascal's law, pressure at this side is is equal to this side. When the force is applied, 10,000 is applied to this piston, it moves inward, and this pressure is transmitted through this fluid, and it is the same. Now we can put the value. We know pressure is force upon area. For P1 it is F1 upon A1, and for P2 it is F2 upon A2. Now we need to find uh, F2. We need to find F2. So F2 is equal to, you are going to put the values. F1 is 1000 into 1 divided by 0.5. So F2 is equal to 20,000 newtons. Now you can see that F1, that is 10,000 Newton force is applied, by it is converted. Since the area is doubled, this force is also doubled. So from 10,000 to 20,000 Newton. So this is how they acts as a force multiplier. A you can see a small force is increased, and this ratio, if this ratio comes out to be 1, it means F1 is equal to F2. If this ratio is greater than 1, it means the force is magnified. So this is the application of the Pascal law. So I hope you understand the concept and the working of different basic working of the different machines. Thank you, and Allah Hafiz.